Did you just say you can charge this thing in 6 minutes?
The most detailed model we have, we're looking at a 39-minute duty cycle, and that comes from telemetry data on the mine already, and we're looking at about a 6.5-minute charge time.
I'm Don Toporowski, and I'm CEO of Rethink Mining. You're listening to the Rethink Mining Podcast. And today, we have a special guest, president and co-founder of Pivot Electric Machine. His name is Michael Collins, and he has this idea that instead of throwing away all those perfectly good diesel machines, let's retrofit them to electric. Let's save a pile of cash while we reduce operating costs and our environmental footprint. It's a fascinating story, and I'm so happy to have you here, Michael. Welcome.
Thank you, Don. It's great to be on the Rethink Mining Podcast. Appreciate it.
So we met for the first time at Mine Expo in Las Vegas. It's been about a month ago now. And I had spoken to so many people. I think it was the third day already, and I was pretty tired. And my colleague, Trevor Kelly, says, you got to come talk to the guys from Pivot Electric Machine. You won't believe the progress they've made. And I said, okay, well, I never heard of them. He's like, this is good. So I showed up there. I think it would be like the typical 5-minute conversation. And 2 or 3 hours passed. And I heard the story of your company and what you're doing. And I thought, this is so fantastic. We got to have you on the podcast, first of all, and try to build a consortium project around what you're doing to help move the technology forward. So why don't you tell the listeners off the bat what Pivot Electric Machine does?
Okay, well, I should preface this whole conversation with I'm not going to keep people on the podcast for 2 or 3 hours. Okay. Nobody wants that pain. That said, Pivot Electric Machines is focused on rebuilding existing heavy diesel, mechanical, and diesel electrical heavy haul trucks to battery-powered powertrain systems and charging dynamic or static charging systems as clients want to have. And the real underlying driver on this is building trucks using existing investment in heavy steel and moving tons cheaper.
So when I hear about the mining industry wanting to convert to electric, I think about all those gigantic diesel vehicles. I have no idea what they cost. But I think is there something like 10,000 haul trucks in use around the world?
There's actually about 46,000 haul trucks in operation over 90 tons. So that's
I think
pretty
about
big
those
fleet.
And the cost to replace them. Let's say you were really conservative in your approach to convert from diesel to electric. And you say, well, whenever one gets old, instead of buying a diesel one, I'll buy electric, and that's how I'll convert. I think, first of all, that's going to take forever. So if you try to do it more quickly, it just seems like the capital cost of replacing diesel with electric vehicles is just insurmountable.
It really is. You're looking at companies like Fortescue who've got almost a multi-decade program to replace equipment in the Pilbara in Western Australia. And their first contract on this is $1.8 billion. And that's the scale of what we're talking about. And the other aspect of it is fundamentally the OEMs don't have the capacity. Worley Parsons or Worley Consulting did a study, and they presented that in a conference in Perth, Australia back in May this year. And they sort of said, look, it'll take until 2050 for the OEMs to replace every truck out there.
So Michael, I heard the same announcement as you when I was at Mine Expo between Liebherr and Fortescue. And I thought they said 1.8 billion, just like you did. But I looked it up today, I found a press release. And they say the deal is 2.8 billion, maybe that was 1.8 billion euros, who knows. But they said it's 2.8 billion in this press release, US dollars, to build an autonomous and electric fleet. And you would think that's gigantic. But that's only 350 trucks. and 475 vehicles in total. If you're saying there's 45,000 trucks of that tonnage and over, that doesn't even put a dent in it for 2.8 billion. So you're kind of in the same mode of thinking as a lot of people. Why don't we retrofit them?
Great opportunity. The interesting thing is that Komatsu is offering to deliver what they're calling battery-ready AC trucks. So they're basically delivering over the next few years diesel electric trucks. So they've got electric drives and a diesel generator sitting in the middle of it. And it's like, oh, it's okay. We're going to put, next time we do a refit, we're going to swap the generator out and we'll put a battery, powertrain system in the power system in there. But not now.
I've read about that from other manufacturers as well, including the deal with Liebherr. Now, I'm not an expert on it, but it sounds like those vehicles as well are being equipped to be converted to electric at some later time. What's the holdup? Why can't it be done batteries right now?
There are issues with people figuring out how to build the battery packs so that they can charge and discharge fast enough. I think I know Caterpillar has a couple trucks that they're quietly out there testing, 793s. But really, anyone can put an electric motor in a truck. But the real hard part is building a battery pack that's reliable and effective and charges fast enough.
So before coming to work at Rethink Mining, I worked at this university in Canada. It was a place called the Automotive Center of Excellence. $100 million was spent to try to advance technologies in the automotive industry. And a ton of our work was around battery electric cars and autonomous cars, of course. Yep. And I would see the advancements and stuff. And I was thinking when I first met you, these batteries they use in cars, they're so well proven. Everyone's using the same thing. They're just going to take a ton of those and stack them on one of those gigantic haul trucks. And away we go. But you're telling me... Pardon me?
Well, like a pile, they call those skateboard batteries because they slide underneath the car and stick them up. So you have a whole pile of skateboards on your heavy haul truck.
But you're saying we can't do that in mining. Why is that?
No, the cooling systems they're using in trucks are relatively passive. There are some Chinese projects and where they're looking at using internal water cooling inside the battery pack, which is bad in a car. But if you've got a battery that's 20 times the size of a sedan's battery pack and you have a little fire in one corner, it's not going to go particularly well. You need better technology than that. And you also need better cooling than that system provides in any case.
And do we need a different kind of battery somehow?
Ironically, we're looking at using lower density batteries for what we're doing, but they are more stable. And also the form factor of the cells makes a difference. If you're using prisms versus cylinders, they cool differently. So you've got advantages and different disadvantages. Our technical teams, built 4 generations of batteries for mining equipment, and has a huge data bank of information on how batteries are performing and how they're cooling, and those things inform how we build these, and that's the big difference, and that's what makes it possible.
So when you say density, you're talking about the amount of power I can store in the battery per, I don't know, cubic foot or something?
Yeah, watts per liters, as it were.
Watts per liter.
So, you've got NMC batteries, which are considered the highest density. Then you've got LFP and then LTO, lithium titanate. LFP is lithium iron phosphate. Those just have a stepping stone of lower densities, but partially because of the lower density, improved safety, and and impact resistance and things like that. So those are all things that have to be considered as you balance what you're doing to build a battery that's going to perform, charge quickly, discharge quickly, and as well not catch fire.
So
and
even though
cold temperatures and hot temperatures, right? Because mining is not sort of a sunny 25 degrees outside every day kind of moment.
So even though the OEMs are making battery-ready vehicles, you believe that the battery technology we have today, you can make work in a retrofit of a diesel vehicle?
Yeah, absolutely. One of the beautiful things about heavy haul trucks is there is actually an awful lot of room on them to put batteries. There are considerations that you need to make in terms of maintaining the designed balance within the whole truck frame. But one of our advantages is that because we are smaller and really in the large focused on battery design, if a change in chemistry presents itself that is significantly better, it would take us a couple of weeks to make a decision to build a better battery. And there really aren't any OEMs who can do that.
So you have a technology that could work today, and if something better comes along, you feel confident that you could adapt what you're doing, just integrate the new technology. I mean, once it's proven to be satisfactory and reliable and safe and all that.
Yeah, there has to be enough data behind it. You can't just take a new idea and chuck it in and hope that it's going to be effective. So right now we're looking at a couple variants of lithium titanate cells, and we've had a long-term relationship with one of the solid-state battery producers or nascent producers. So we're always looking for what is going to deliver the best result for our customer. And so it's got to come down to not only density and charge and discharge, but the fundamental, how much is it going to cost to move a ton with this?
Yeah. So you just said you can't expect someone to take a new technology and just chuck it in. But isn't that what you're doing? You're asking these mining companies who've been operating these haul trucks just fine with diesel for, I don't know, 80 years, is it 100 years? A long time. And you just want to chuck in an electric retrofit. And you just said that can't be done. What makes you feel confident that this is going to work?
All right. So one of the key things is the vast majority of the subsystems that we're applying to these larger trucks have been commercially applied in smaller vehicles. So we're scaling them up, but we're not creating new technology to drive this. For instance, Emissions Reductions Alberta that we've been working with, they've rated our technology level as a technology readiness level of 7, which sort of is everything is kind of there. It just needs to be put together and driven off the lot. So that's kind of, I think, a critical factor in de-risking what we're doing for our customers, number one. The other thing that you'll see in mining is there's really a ruthlessness. You have a mine design that's put together, and then the company and its consultants will go out and they'll look at the various trucks that they might use in it. And 1 or 2% in improvement in performance between one company's offering versus another, that's what makes the difference in the truck that they buy. That's how small it's granular in terms of looking at what they need to get in performance out of their equipment. So if we can offer, a significant improvement in their actual performance of their vehicles, their availability, and the cost per ton of moved rock, then it's kind of a winner, hands down. We just need to get some trucks on site. So
I was reading that global emissions from mining haul trucks represent something like 2 to 4% of the entire world's emissions. Could that be right?
Yeah. It's if you're looking at this from a greenhouse gas emission perspective, it really matters, right? This is This is something we can hit really hard, and we can make a change that matters. If we build a couple cars, it doesn't really matter. Your average car gets driven 53 minutes a day, and then the battery, which is carbon intensive to build, sits in somebody's driveway or garage. These things run 23 hours a day. It's like super effective use of technology and resources.
And I also read that something like 60% of the cost of surface mining hauling accounts for 50 to 60% of operating costs for surface miners. So, of course, if you can convert a diesel truck to electric, or let's say you get rid of your diesel truck and you buy electric, you could have a massive impact on greenhouse gas, right? Huge. But the thing is, while that's important to everyone in the world, it's important to mining companies, it's important to business. At the end of the day, economics tend to drive decisions a lot faster. And I have a feeling, I don't know the mathematics, but I have the feeling throwing away a perfectly good diesel haul truck and buying an electric one, there's zero economic case for it. The payback probably can't even be made in 20 years, I'm guessing. But if I can retrofit it, I bet I get a really strong financial case that dwarfs the benefit of the greenhouse gas or emission reductions. What do you think about the economics on this?
Yeah, well, if you look at apples to apples, just for remanufacturing a diesel truck, they generally expect a remanufactured truck, which is good as new, runs the same, etc., is about 20% cheaper to take a frame and rebuild it and drive it off the lot, and you'll have the exact same performance. And they do that globally now. So there's an acceptance out there that remanufacturing of fleets makes a whole lot of economic sense and is actually very, very sensible. So to take that remanufacturing opportunity and just slide in a battery power system at the same time, it's kind of a no-brainer. You're looking at, in some cases, over 100 tons of steel that you're not, rebuilding again. And it looks very, if you look at the battery electric trucks they're offering now, they look pretty much exactly the same as the existing diesel trucks that they're selling.
So you're going to take an existing diesel vehicle, you're going to remanufacture it, and in that process, you're going to convert it to electric.
Yeah, exactly.
So that conversion, the extra cost of the conversion, I imagine it's got to be a couple $1,000,000 for a truck, doesn't it?
Yeah, so looking at a 231 ton truck, we're looking at a conversion cost of about 1.6 million, and we think we can get that down as we go to scale. So instead of buying, one or two motors or inverters and things like that, we're looking at buying 20 or 30. We should actually see a cost component drop of, I'm thinking 30 to 40% is what we're talking with vendors, and that's what we think we can do there. So long term, if we can do a remanufacturing at 1.2 million for a truck, and then probably another 1.4 for the battery for our base case economic model, it's very competitive, even for rebuilding it as a diesel. So,
and what sort of return on investment do I get on the money I spend in converting it to electric? I imagine electric, is it cheaper than diesel? Or the cases you want to apply it, you want to find cases where electric is cheaper than diesel. So what's the direct payback?
Certainly, we certainly it won't work in all cases, especially situations where your diesel power is your power is produced by diesel. So if you're working in the far north in Canada, you're actually looking at increased efficiency by using electricity in the truck, but your power losses between charging and discharging may outweigh using a central generating system. But it's not that significant. But on your average mine operation in North America or South America, where you're looking at standard diesel costs and pretty average power costs, it makes sense. It really works.
I had been hearing for a while about the idea of converting haul trucks to hydrogen fuel cells. And a lot of people were really interested in that. Doesn't sound like that flew. So now people are back, they're interested into converting to electric, just as you're proposing. What lessons are there to learn from that attempt to convert trucks to hydrogen? Like, what can we do different than electric that makes it go faster and gives a higher adoption rate and makes people say, wow, let's keep going?
I think number one, we've got to look at the right opportunities and look at the base economics to start with. One of the reasons why I think there's difficulty with hydrogen is the cost of infrastructure around it. And when we look at implementing, battery electric systems, number one, the infrastructure costs are lower, but they're also a lot simpler and they're off-the-shelf technology. So we know exactly what we're getting into. If you're going to buy a transformer, it costs X. They've been building them for hundreds of years. If you're going to put in a hydrogen fuel line and storage system and refueling, the technology there is certainly, there's been adaptation, but it's one of those things where it's relatively unknown and tends to spiral with detail engineering. So we have more certainty, I guess, in playing with electricity. If you look back, the fights about how electricity is going, what's the most efficient way to move electricity, Tesla and Edison fought over that for years. And there's still people who actually think that DC transmission is more effective and cheaper. They've got some good points. But fundamentally, those arguments are solved. So we're applying known factors as opposed to coming to things from grounds up, if that makes sense.
So do you feel like the environment or the attitude towards electric retrofit of diesel vehicles is different today than a few years ago? Or do things feel the same to you?
I think now people are, a few years ago, companies started making commitments to reduce greenhouse gas emissions. And at the time, they're like, oh, we should do trucks. Trucks would be interesting. And they'd be impactful. But the problem with them being impactful in reducing greenhouse gas emissions is they're also impactful in terms of the profit margin of a mine. And that's what they quickly realized. So no one really wants to experiment with their own trucks on site. They need to see a solution that's going to, it's going to happen. They're going to drive out of the garage and go to work. And whenever you, put new technology into a mine site, there's a whole lot of training that goes on around that. But fundamentally, people have been and are afraid of that. However, today, as we head towards 2030 and they still have these, 30% reductions by 30, and they've been, oh, look, we've got an electric bus. Oh, our utility vehicles, which use, 20 liters of fuel a day. We've converted our utility vehicles. Yes. All of that's important, but if the truck that goes roaring past the utility vehicle is using 6,000 liters a day of fuel, it kind of begs where you should be focusing your effort.
So if we look at the automotive industry, the engineers working on that, they had this idea that the future was autonomous and electric, and they went hand in hand. Mm-hmm. And it kind of makes sense that if you're going to bother having an autonomous vehicle, which is basically a computer on wheels, why not make the thing electric? But for all that effort and all those engineering teams working together, in the end, what happened was the notion of electric got advanced more quickly. You see electric vehicles working everywhere. They're fine. Autonomy has lagged. And it might be ages before we see, widespread use of autonomous cars.
Yes.
But in mining, it seemed to have been the opposite. People were talking about, well, the haul trucks should be autonomous and they should be electric. And I met the guy from Komatsu the other day. He says, oh, no, we've been running autonomous diesel trucks for 20 years. We've got it down pat. It's such a controlled environment. There's no baby carriages. There's no soccer balls. There's no kids running around. Autonomy is easy. And yet the electrification part is miles behind. So what's your ideas on why the electrification is so far behind?
I think again that is so autonomy is computer engineering, and it's something you can turn on and off. So it's a whole lot easier to test on a mine site because you're basically running it in a truck with an operator sitting in the cab, and it's an incremental cost, a very small incremental cost in your overall mining cost. And if it's not working, if you hit the red kill switch and the driver, puts his hand back on the wheel and his foot on the pedal and keeps going. If your battery dies before it gets to where it needs to recharge on a truck, then you've got a truck full of ore or waste sitting in the middle of a road blocking everybody else. And that's just an untenable situation. You've got to be able to deliver a product that is operationally effective right out of the gate. And it's a much higher bar to go across.
And so you have an idea of how to build confidence with miners that this is feasible, it's reliable, it's going to work. And when I heard the idea, I thought, well, this is a thing Rethink Mining can really help you with.
Yeah.
Our organization is 20 of the largest and most innovative mining companies in the world. And when they find an idea that they like, that can help them meet their goals, they rally together, they put in resources, people, cash, and try to move it forward. And what got my colleague Trevor so excited about where your company is now, it sounds like you're really on the verge of that. And it sounds like a project that you're putting together here that our members could join in and participate in. So tell us about the pilot you have planned in Western Canada.
Yeah, so we're based at Edmonton, and our focus is bringing a 793 Caterpillar 793 truck to Edmonton, breaking it down, rebuilding it as a battery electric truck. We've secured access or agreement for access to a former coal mine site to the west of Edmonton as our proving ground. And we'll be basically loading and unloading that truck and running that back and forth to demonstrate it there and work out all the kinks. And then we have an oil sands operator who's agreed that they would let us deploy that truck into an operational environment in the oil sands where we can demonstrate that it meets the performance metrics that are required to be in a commercial fleet. And I think that's what we need to see to give people confidence that, yeah, this thing will run day in and day out.
And you have some funding at this point as well to help move this forward. Is that correct?
Yeah, so we've got an investor who's looking to put in about $2 million. We've got a government grant that we're hoping will come through relatively shortly for another 2.8. And one of our key shareholders and prime contractors, which is Prairie Machine in Saskatoon, is looking at investing a significant amount of money as investment in kind for work that their team will be doing. Really, Prairie Machine builds Rokion light battery equipment and have been doing that for about 12 years, that team. And they really form the technical backbone of what we're doing. And they've got a depth of experience in building batteries, cooling batteries, operating batteries in 50 degrees C and well below zero in northern Canadian temperatures.
Okay, so tell me, the project you just mentioned, what would the total cost of that project be to conduct?
We're looking at about 10.5 million for that. And at this point, we can see about 6, and we've got some other investors that we're talking to as well to bring this forward. I think we're hoping that we'll get enough funding in the next 2 months that we'll be able to order long lead items, as well as starting to get some detailed engineering on some key aspects that hasn't been completed yet.
The members of Rethink Mining have expressed real interest in this sort of thing. So I'm hoping that a few of them come together to support the project, participate, and learn from it, and help your technology advance. What do you think this pilot is going to help prove about the technology and the application? Like, what sort of data are you hoping to collect?
What we'll be looking to do is demonstrate the battery operates within an acceptable temperature range when it's at peak discharge, and as well that our methodology for charging is effective in terms of how quickly we can pump energy into the battery and get it moving again. Our base model and our base economic case, which is based on a deep mine pit in South America, has a static charging system in it. So we're looking at a little over 6 minutes for our charge time. We need to demonstrate that works. And if we can demonstrate it works, we can demonstrate that we can actually make up enough time in other aspects of the duty cycle of the truck that it will cover off on most of, if not all, the charge time on a static system, which is really the cheapest way to charge a vehicle. Or fastest, and cheapest as well, actually, both.
Just a minute.
In overall.
Hold on. Did you just say you can charge this thing in 6 minutes?
Yeah, so we're not looking to do a full charge on the truck. We're actually looking at a 30% charge of the full stack, and then we're looking to use regen to bring it up to a higher level, closer to 100. Because when you do regenerative charging, you can't push it into the battery at 4C. You can push it in at 1 or 2C. So it's the regenerative aspect of charging is better suited for downhill for the top end of the battery. When you're charging from 80 to 100%, there's more resistance within the battery pile. So you've got to think about how you're charging your battery too. So you've got more resistance in the battery pile, and if you punch the energy in too fast, then it will overheat, right? So you've got to slow down your charge rate as you approach 100% charge capacity.
So what would you see as, let's say the big truck is doing its thing, it's going up and down the road with its loads. Like, how often do you think it would have to be recharged, and how long would it be out of service on the charger?
So in the base case, the most detailed model we have, we're looking at a 39 minute duty cycle, and that comes from telemetry data on the mine already, and we're looking at about a 6.5 minute charge time. So, and we've actually, with the chargers that are available now, we think that may be able to be shortened a little bit.
So how does that fit in with how they're operating now? Like, if I got to go charge my thing every 39 minutes, isn't that a huge disruption to the operation?
Well, it is, but you put it in line with the routing that they're already on. So it makes it fairly, there's no detour in the whole process. Number one, I guess you're also taking things out of their daily cycle. You're not, with respect to that business case, we've got a delay report file of over 30,000 delays. That represents, an enormous amount of data. So you can look at things that would be relatively unique, like oil changes. And if you had, 1 or 2 oil changes in a very small data set, you wouldn't know what that represents. But if you can look at that data set over a month and say, okay, this is legitimately how, in multiple trucks in a fleet, this is how much time they're spending every day on oil changes. This is how much time it takes for management to approve the oil change that just happened. all those little things. You can also say, how long does it take it to fuel with diesel? Twice a day. So you're going to do that twice a day as well. So you look at all those things and you say, okay, well, these are diesel costs in time, and you compare it to what the relevant costs are with battery electric, and we come up with a fairly similar overall timing for using battery electric.
That makes sense now. If I'm going on a route and I know how long that route takes to load and then drop off and then go back again, I just make a little stop once in a while for 6 minutes, charge up, and carry on, right?
Yep. Yeah, and the other side of it is, they're just, you don't have the same constraints driving uphill with battery electric that you do with diesel. You can only drive a diesel uphill at a certain rate, and if you can swap out your entire fleet, you should actually have faster uphill driving time with battery electric because you can apply more energy.
Repeat that one for me if you don't mind.
So a diesel engine has a certain set amount of power in it, and you get into the top gear and you're at the top of your power band, and you've got a certain amount of weight, it will only go so fast.
What do you think the future is in battery technologies? Like, is there anything coming down the pipe, in the next few years that could dramatically change things for your company? Like, are capacitors a potential technology that could be put to use?
Yeah, we're seeing capacitors as something that may be additive in terms of applying torque on motors for soft ground applications. It's entirely possible. Right now, one of the problems with capacitors is relatively low energy density. So right now we're wrestling with how much they weigh in terms of putting them on a truck, but we're looking at the potential for capacitors for faster charging and discharging in a static environment, and being able to move those trucks even, improve efficiency beyond what we're looking at in diesel as a static charging option.
Are there any other technical issues where questions come up repeatedly about them in converting diesel to electric? Things that people worry about? Charging time obviously is one. Range would be another one. What about things around safety? And then, let's say disposal of the batteries down the road.
Yeah, so safety is always top of mind in a mining environment. The key thing, I think, is the level of sophistication in the batteries at this point. We're looking at temperature monitoring on a cell level, or at least on a submodule level. So you've got an awful lot of information, and you can cut blocks of cells out as required to make sure that fires shouldn't happen in batteries if they're properly monitored. That's the reality of it. You should be able to detect it and simply shut it down and isolate a unit. And if you're using a module system on your trucks, then if there's a problem with a module, that gets shut down. If a couple modules, God forbid, got shut down at the same time, the truck would drive slower, but it wouldn't shut down, right? It would still be able to do its job. And that's really, you've got to be safe, and you've got to be continually operating. And those are the things that are kind of key. What was the other point that you had? I think was
safety. And then the second one is, what are people's typical concerns about battery disposal at the end of life?
Yes. Actually, so this is one of the beautiful things about battery electric trucks is you're looking at such a significant volume of one chemistry of battery, it suddenly becomes very efficient to look at reprocessing that material and reducing it to the discrete metals it came from, and sending that back into the the battery economy, or whatever. Copper goes where copper goes, but lithium's going to batteries, and that's kind of a key aspect of it. I think a pretty neat aspect that if you're a battery recycler and you've got 1.5 tons of one type of battery and 3 tons of another, well, you can't mix the two when you try to do hydrometallurgy on them and get the elements out of it. But if you've got one truck that's got 6 tons of batteries and you've got a fleet of 45 trucks, then that starts to make sense. It's like having a bunch of little tiny deposits, mineral deposits that you've got to do metallurgy on, or one really big one. Everyone wants to work with a big deposit metallurgically. So why would you want batteries from 6 people, right?
Now you're talking the miner's language.
So, yeah, big deposits.
So coming back to the safety thing, I imagine like a battery fire in one of those trucks with all those batteries, that'd be awful. But if you're going to test it and prove it and monitor it and be careful, surface mining obviously is a place to start. But I saw in your technology path plan forward, you were planning to do a scoop next for underground.
Yeah, we've been looking at working in the underground environment as well. One of the key things that we think will make a huge difference there is when we start seeing solid state batteries entering commercial production. And you'll have batteries that, are 2.5 times the density of existing batteries in the marketplace today. So the whole question of, do you need to swap your batteries underground or doing things like that? The length of time that you can actually run a vehicle on one battery, it starts to make more economic sense. And we're pretty excited about that space, but we're waiting for the technology to mature. And also for looking at it and sort of saying, okay, well, we need to find partners in underground mining who are more open to what we believe are the opportunities than the current technology that's being applied underground. We don't think it's there yet.
Can you explain to us what a solid state battery is and how it's different from batteries people are familiar with?
Okay, so the batteries that we're seeing today all have a liquid electrolyte in them. And the liquid electrolyte is what allows the ions to go from the cathode to the anode. And then when you discharge, go back again. The fire hazard generally in a battery and in the explosive. So the battery heats up one way or another. It short circuits, or there's a chemical reaction or something like that. It heats up. The electrolyte starts to turn to gas. It gets really hot. It explodes. More air gets into the battery, and then all things on fire. That's not exactly right, but that's close enough. If you take the liquid electrolyte out and you have a dry battery or a solid state battery, it's a whole lot harder to set that thing on fire, even if you overheated it. And I've seen some pretty compelling test results from solid state battery companies that demonstrate that they're a whole lot safer than any of the liquid electrolyte batteries we're seeing out there today.
So the future of battery technology, we're all pretty optimistic about it.
Yep.
For the people who are really into the technical nitty gritty, tell us how you retrofit a diesel, let's say haul truck, to electric. Like, what do you do with the transmission? I'm imagining you don't put a motor on every wheel. How is it done exactly, technically or mechanically?
Yeah, so you can't really put a motor on every wheel without, really cutting the frame down and rebuilding it. And at that point, the engineering and design work is the risk goes up, because those are you don't want to mess with the frame. So one of the key things that we have to do is make sure that when we're hanging batteries and motors and inverters and things like that on the truck frame, that it still sort of mimics the existing weight distribution and hang points within the frame, so that it doesn't. We don't want to get to 2 years down the road and have a whole bunch of frames cracking. Kind of critical. So we've got we take the motor and the transmission and the driveline out, and what we're looking at is joining sort of driveline transaxle to the back of the truck to the motor through a gearbox, and then you've got an inverter in front of that and your battery pack, and then your charging system on the side. So it's fairly, and it all kind of fits into the same space. If you look at the way other companies are doing it, people are stacking batteries on the deck. You can do that, but you also have to be concerned about not making the truck top heavy. If you're adding weight on the top and taking it off of the bottom, that's not going to go well either. So you start, you've got to make sure that the center of mass forward and aft, as well as vertically, is very similar to what existed previously. Things like that. So those are concerns, but it all goes together.
So Michael, coming back to the idea of the Rethink Mining members participating in a consortium to advance your technology, of course everyone wants money, but I'm pretty confident you're going to get that one way or another. But if mining companies were participating in this project, what would you want from them exactly? How would you want them to participate?
Yes, thanks, Don, with that one. That's kind of a key thing for us. I guess funding is difficult, and it would be great to have financial support. It would be even better if someone had a donor 793D truck that they wanted to share with us. But really what we want is people to get involved, watching what we're doing, giving us feedback as we move forward, so that when we get to the end of this and we have a truck that's commercially deployed, it's doing what they also think it should be doing. We expect to have it capable of doing what the one operator will want, but we want to make sure that everyone has their questions answered. And at the end of this, commercial deployment says, okay, yeah, we could see a place for that on our operations too. These guys know what they're doing. This is going to work.
Yeah, you're not the first to say that. A lot of the companies we deal with, they're like, hey, money is great, but what I really want is the attention of these people. And myself and my colleagues here at Rethink Mining, we're really optimistic about this technology and its potential to succeed. And we're hoping that some of our members come together, support your project in Western Canada, improve this technology, and help get all the economic and environmental benefits we hope for when we convert to electric. Thank you for joining us today, Michael, and good luck to you and your team at Pivot Electric Machine.
Thank you, Don. Really appreciate the opportunity to present what we're doing, and it's just been great talking with you in any case.
We'll see you again. Thank you.
Okay, thanks.